All right, so let's talk about items of business here, or the reason that we're here, which is to kind of feature the work of our second semester students. And
my name is Naomi Yates. My project is about the California water crisis. This project started for me last summer when I took the projects class, the QGIS projects class. And the project that I did with Matt, partly, was looking at water districts in the state of California and seeing who uses more and who uses less. And it was also investigating the state of the different dams after the Oroville Dam almost flooded the valley. It was still, on everyone's mind, that aspect of the California water situation. But I wanted to make a project that kind of put all the dots together, because when I studied the data sources for water extensively last summer, I found all these silos of data, and they're all really good data, but you've got the California Water Board data, and then you have data from the Bureau, the people who run the Central Valley Water Project, and then there's the State Water Project, and then there's all these different people collecting data and analyzing data, and you don't always get them to talk to each other. And then specifically, we were trying to visualize who actually uses this water and how much do they use relative to one another. And there wasn't an easy way to do that, because there was the State Water Project list of how much water different districts got, and the Central Valley Water Project list that were separate. So in last summer is when I did the big data clean of merging those two lists, recoding them so that the names were spelled the same way as the names on the shape files that you could get for all the water districts. The California State Geoportal is amazing, and there is so much on there. That's where most of this data came from. So I had all of that already when I started this project. And so I really wanted to connect these little pieces of the puzzle together. And the main things that I thought of were, as you can see here, the natural water system. There's the way the rain falls, the way the snow is kept in the ice packs in the mountains, the way the watersheds work together, what places are wet, what places are dry, temperatures, all of that, because California has this amazing diversity. And then on top of that, there's all of this water infrastructure that we've built over this last century of the dams and the reservoirs and the canals and all those things. And then sort of another layer on top of that is the legal infrastructure that we've built. Who has water rights? How do they share water between each other with water rights sales and leases? Who has jurisdiction to tell who how much they can use? Who's making the rules about when you pull it out of the ground? All of that kind of stuff. And then of course, the actual procedures. Who gets to use how much? What do they use it for? And all of that. That's more the third map of allotments. And then also conservation. Are people conserving water or are they not? And then my last map was about, okay, so all of this is our situation. What does this make us look for in the future? So I'll try to zoom in just a bit on each map. Maybe that would, oh no, that's perfect. First, with my natural water system map, the colors that you see are showing not just precipitation for a year, but the 30-year average. So for the last 30 years, the average annual rainfall for each of these, all of these places in California. This is put out by the University of Oregon. And it was important to me to use data sets in this project that were all based on real data. No, none of it was based on models. It was all based on real data. And it was also long-term data, not just short-term data, because we are in the middle of such change that it's important to look at it over a long span of time. So the colors show blue is more the lot of rain, kind of the grayish is like, what's rain? I also have the arrows going up and the arrows going down, and that shows you where the snowpack since 1955 till 2020, I believe, was that averaging going up or going down? Is that a bigger snowpack there, or is it a smaller snowpack? And all those red arrows going down kind of speak for themselves about, are we having more snowpack now? No, we're not. We're having less. But at the same time, this has been a stable ecosystem for a very, very long time, much longer than we have data for. So over here on the human water map, we could maybe even zoom in a little bit further. We take a look at what we have built on top of what is naturally here. So as you can see, the purple is where we have population density. And I took great pains to show pockets of density that are maybe not a whole lot of people there, but compared to the area around them, it's high density, all on the 99. It's like everybody in California who doesn't live in LA lives along the 99 in the Bay Area, and then up on the 5 between, Redding and Sacramento, pretty much. And so we've put all these people in the state in some of the worst places to have cities, especially down where 50% of the population lives is down in the desert. And we need to send them a whole lot of water. And then we've put a huge area of agriculture, which is important internationally, is in this extremely dry region. You can see on the map next to it, it's not got a lot of rainfall. And so you can see the orange lines are all these canals that we've built to pull water from water sources to irrigate that cropland and to feed those cities. And these cities and that cropland are really the backbone of the economy, which is the 5th largest in the world. So it's a big, big deal. So then the real hours in this project were in trying to get all the data consolidated between the different sources to accurately reflect who is using water right now. Because this year, 2 different times, the allotments have been shifted because of different rainfall that happened, and they shifted them. But right now you can see we have, oh, this is my old one, Dan. The one on here looks like it's the old one, but that's okay. This shows you in February, this is what the allotments were. I've since updated this map because the allotments have changed. And now what you see on the screen, there's this 2 big green, which are agricultural irrigation districts, and then the blue are cities. None of these are as big anymore as they are in this map because they've all been reduced. So the size of the icon shows how much water they use relative to one another. And then there's another data set, which was from the California Water Board about comparing 2020 to 2021, the second half of each of those years. Were people using less water or were people using more water? So an arrow going down means they're conserving, they're using less than they were the year before. The arrow going up means they're actually using more or the same as what they were. And then the size of the arrow is based on how much actual allotment they have. And so you can see there's regional differences about how much people are conserving. But if you add up the amount of water district requests at 12 million acre feet, and then compare that to the size of the amount that is in our reservoirs now, which is 15 million. So clearly we're not going to use every drop or almost every drop of our reservoirs this year. So it's not really a sustainable situation that we have, which is why they're cutting people off from the water they would normally be getting. So in my last map here, context and impacts, it shows the CAL FIRE fire threat layer, which is a low to extreme fire threat. And you can see lots and lots of very high and extreme fire threat in the state. And then all these teardrops are where you have private wells going dry. And this is not a thorough data set. This is just self-reported, where people's wells are going dry. And then here, the aquifers that are critically overdrawn, you can see a ton of these wells are in those. And then you can also see where these municipalities, agricultural districts, all these that have been told you can have 6% or less of your allotment for the year. Naturally, what are you going to do if you don't get to take water from the canal anymore? You're going to take it out of the ground. You don't stop irrigating. You don't stop drinking, bathing, running your factories. You just take more out of the ground. And so my concern is that as both government and industry have been putting more emphasis on creating more storage and moving more water, there's even been talk about moving water from the Mississippi River or from Oregon to the state of California, without taking a look at reality, that you can't just suck your aquifer dry. All of your plants and animals will die. And we looked at all these parks in our maps. That's a huge thing for our state. It's a huge thing for anyone, but it's especially a huge thing for our state. So I was having too much of a good space in my head, so I chose to do this California water crisis map to make myself really depressed and concerned.